cái if config sửa quăng cho file environment. If config chứ đi.
Rồi.
Rồi hả? Okay. Hello. Okay.
So good afternoon, everyone. So welcome to the session Service Mesh on AKS. The future is now. So you are a team here in Vietnam. So basically our English is not so good. So sorry for any misunderstanding or confusion. So let me introduce myself first. So my name is Phi Huân. I am Senior Innovation Manager at Nasdaq. And coming along with me today, we have Thắng Trung, Senior Solution Architect, and we have Phương Lê, Senior Engineering Manager. So we are all working for Nasdaq Global Company, and we also co-organizer of Dev Cafe channel on Facebook to sharing the latest technology to the community. And we also have some open source project hosting on GitHub, and we work for VM Dev organization on GitHub. So very nice to meet you here today. So firstly, I would like to share what we do at Nasdaq Global Company. So basically, Nasdaq Global is an outsourcing company. We develop software solutions for the clients around the globe. And so these are the services we are currently working for our clients. So the session today is sharing about how we apply emergent technology for our clients' projects, especially the service mesh technology. But going back in time, around 10 years ago, we mostly developed, traditional desktop application, develop monolithic application, and we mostly apply very old technology, right? And then we move on to end-layer architecture, right? For example, we apply end-layer with cross-cutting concern layer, and then we apply modular architecture to our clients' projects. And then several years ago, around 3 years ago, we started to apply microservices architecture to our client projects. And recently, we trying to apply the very new technology, which is called Service Mesh, to our clients' projects. And that's why we are now here to share with you how do we apply this kind of technology to the projects. So most of the clients, when they come to us, they usually ask us for how to apply emergent technology, because these days, the technology is changing so fast, right? But not all the projects at Nasdaq, we apply the latest technology. So there are so many projects still running on very old technology. We call legacy system. And but when they ask us why we go with microservices, right? And it's not just, it's very complicated question, and there's no immediate answer for this kind of question. And it's usually a journey to that kind of stuff rather than, going quickly into, okay, we go with microservices. And we want to share with you one story. For example, one client of us, which is Evolution Wellness. We built a system for them around more than 5 years ago. And with that system, we built basically, Evolution Wellness is a very big gym aggregator in the UK. They maintain a lot of gym clubs in the UK. They manage the member profile for gymmers, and they manage the timetable for the gymmers. So basically, we build all kind of activities for gymmer and operators for the gym clubs. And everything just fine with monolithic application, right? So the client is very happy for that. And then they try to grow their business to other markets. And they expand the market into Asia, for example. They scale the market to Thailand, to Hong Kong. And they require us to, expand the software into this market. And the way we do is, we just, refactoring the code of the old code base from the UK one into Thailand and Hong Kong. And the way we do, we just, inputting into the code, just if else, and then for each market, right? And then the system quickly becoming into some kind of, messy, because it's still a single monolithic application, and it contains all of the code within that system. And it's quickly turning into some kind of big bundle of mud. It's very messy. And it takes so much time to develop new features for each market. And it's very hard to maintain the code base. And basically, it takes around 6 months to run out for a new market. Then the next problem is about the deployment issue. The whole solution we deploy mostly on-prem, basically we run on-premise. And for every market, we need to remote desktop into a Windows machine to deploy the new system over there. And because we also have integration, continuous integration system, so that we can automate the build, automate the test. But for deployment, we still do manually. That's why there are a lot of error-prone, manual, and it takes so much time to deploy. And every changes for a very small subset of new feature, we need to deploy again and again for every market. And it has so many errors, and every deployment time is some kind of scary deployment time. And it's very hard for the team to maintain, to deploy, and to run out to the market. So that's why we need to think about the way to re-architecturing the system in a new way. And at that time, we look around into the market to see, hey, okay, what kind of technology this day we can apply for to re-architecturing the system. And that's the time we've made a very important decision, and we go with microservices. And at the same time, we do two important decisions. Firstly, we do the lift and shift for the whole system into the cloud. And secondly, we partially build in a new system for going with microservices architecture. And the idea when we go with microservices is quite simply, the team just go in with a single monolith application and then split into multiple single services. And we have a very good business analyst, which is understanding well about the old system, and then they can confident to quickly chop out into the isolated body components. And the approach with microservices from our project is quite similar to other approach on the market. Is that we also have the gateway, we also have the aggregated services, we also have the services, and we also have polyglot databases. And we try to leverage the power of Azure. For example, we go with Azure Kubernetes services. Why we choose AKS? Because we love containers so much at Nasdaq. So every project, every greenfield project, we mostly apply containerization technology. And that's why AKS is a very good match for this, right? And for database, we also, for database and storage, we also use the managed service from Microsoft Azure, like Azure SQL database, like Cosmos DB for global distributed databases. And the way we leverage the power of Azure is that we will get help from Azure to maintain the infrastructure for us, right? Maintain the high SLA for us. And then that's the time for the team to focus on develop new feature rather than taking care for the infrastructure or things like that. And at the early day of developing microservices, the team is running quite well because it's very good at the early day. But then it looks that the team quickly face so many problems. And the first problem is about communication. And we quickly realized that microservices, life is not a better process. Why communication problem is a pain point for us? For example, the service now, they are running separately, right? They're running on many servers or many containers. That's why from service A connect to service B, how to locate the exact location of the containers of the service B is quite important, right? Even the service B can scale out into multiple instances. It's become worse, right? And it's even become worse when one container can be failed by somehow. And it's very hard to look up exactly the service for connecting to, because they are now not living in the same house anymore. Then, the second problem is the latency problem. From one service connected to another service. Now it's not living in the same house anymore, so now we apply, for example, although we apply REST endpoint sitting at front end of every service, but that kind of latency happened because it needs some time to connect from one endpoint to another endpoint, right? So REST API over here, it looks not a good way, and we need to change it to some other mechanism. For example, we go with gRPC. And this is a very good statement from Medium. And the challenge with microservices is not just building the services itself, This is about the communication between the services. And the second issue when we work with microservices is about how to ensure the security for each individual service. So go back in monolith application, when we build a single monolithic application, we usually build a cross-cutting console layer, right? And then we put into the layer, for example, authentication, authorization, login catching into the cross-cutting console layer. And then every component in the big single monolithic application can get the benefits of that layer. But now it's not anymore, right? So for now, we are many services running in the cluster, and from the service to service, they are living in multiple houses. And how to make sure that each individual service can get secure is very important factor. For example, the man in the middle can attack into the connection between the service to service. It's HTTP, right? And how we can turn into HTTPS for every service. And then the service, is it secure by, for example, authorization, RBAC, like run-based authentication for every services, right? So how can we protect that? And the man in the middle can sit in the middle and get easily to get our data. Right? Of course, we have at the front door we have API gateway to secure our services. But then the people in the middle can get the data easily. And how to secure this kind of individual service is quite important. And the next point is because we are now have a lot of services running in the cluster, and it can have the issue somewhere in our cluster, right? And if one issue happens, how do we trace the issue to quickly fix the issue is a very important factor as well. With monolithic application, we can quickly debug into the application, and then we can know where is the issue. But for microservices, it's another story, right? It's not just synchronous communication. It could be asynchronous communication as well. For example, when connect from one service to another service, they can use event streaming to discuss each other. Then if one issue happens, the issue maybe even works. That's why we need a very good mechanism for login, for tracing, for monitoring, so that we can know exactly quickly where is the issue. Is another very important factor as well. So with all of these kind of difficulties, the team think about how to resolve that kind of issue. And firstly, we think, okay, we need to code everything to fix those kind of issues for microservices, right? But then we can't do that because we need to have time to focus on developing the business feature rather than focusing on non-functional requirement, right? So at that time, the team looked around to the market to see what kind of technology or tool set to fix this kind of issue of microservices. And we see that service mesh is a new kind of technology, can improve the productivity, can improve the security for microservices. And we saw that Istio is a very good name for that kind of stuff. And we tried with Istio, and we saw that it quite, applying good to our project. So we call Istio is our rescuer. Yeah. So what is service mesh in a nutshell? So basically, so rather let the service A to connect to service B directly, right? So the service mesh will add another layer, and that layer called sidecar. And basically, the sidecar will sit in front of every service, and it will be taken care for the connection between the services. So rather than directly connection between the services, the sidecar will take care for that. And the sidecar also can, turns the connection into HTTPS connection. It turns the connection into gRPC connection, for example, and it's also enable the connection into authentication mode, or it also enable the authorization for the service to service as well. So at that time, it means that we can focus on developing the business service, and we let the sidecar do NFR for us. And the second good point from Service Mesh is that it can enable for you to apply the very modern deployment strategy. For example, we can go with blueprint deployment strategy, or even better, we can go with canary deployment. So for example, over here we have two services and two versions of Service B. Service B, we have two versions, version 1 and version 2. And then we can flow the traffic to the new version slowly and slowly. And when we have the new version, right, we can flow the traffic, for example, just 10% at a time. And then we test the new version, and when it's running quite well, and then we can, gradually flow the traffic into the new version. And then it runs stable, we can replace the old version. And with that kind of mechanism, we can have a good way to do the deployment with Sapphire. And at the left-hand side, we call data plan. And the way the sidecar can control the things is controlled by the control plan. So basically, from the control plan, the DevOps team can apply the configuration, apply the policy to control everything from the data plan. And those kind of configuration you will affect into the sidecar. So basically, Envoy is working very well for this kind of stuff. And with Istio or Service Mesh, it also supports us for support services because like login or tracing or monitoring, because for microservices stuff, how to trace the issue is quite important. So that's why Service Mesh can help us to plug the provider, the APM provider. For example, we have Datadog, we have Dynatrace, or many other solutions, and we can plug into the Service Mesh provider over here, and it quickly turns out into a very good monitoring solution for us. And these are a very basic idea for Service Mesh, and Istio, we can go to Istio documentation for more detail. So this is the case study I just mentioned before, which is for evolution wellness solution. So basically, we try to apply a lot of managed service from Microsoft Azure, like AKS, and then we deploy Istio on top of that. We also leverage the databases technology from Microsoft, like Azure SQL Database, Azure Cosmos DB. As you can see, we also maintain a very big legacy system. Remember, first is the legacy system. And the way we maintain the old one and the new one is that we apply strangler pattern, we apply anti-corruption layer, so that the new changes in our system or the issue in the old system, it doesn't affect together, right? And to keep the purpose of the system like this, our client requires us to build, a very scalable, dynamic, and observable and resilient for our client. So that's the purpose of this kind of system. And this is the deployment strategy. So basically, we apply DevOps culture to the team, and we apply fully CI/CD to the projects. So every time commit the code, and then everything will be triggered. And we use Helm to package every changes for our services. And we use Azure Container Registry for storing the images. We use AKS to deployment for cluster management. And as you can see, we use namespace from AKS so that we can apply multi-tenancy architecture over there. And we also have Slack for collaboration and Datadog for monitoring. So this is our preferable technical stack for now at Nasdaq. So at the very bottom, we have Azure infrastructure, and we have AKS with a lot of pods. And on top of that, we have a lot of open source products like Istio for Service Mesh, Envoy for sidecar proxy, KLE for Service Mesh visualization, and we have Jagger Elastic Open Tracing for pushing all the way up the login into APM so that we can have a very good visualization. And then there we go. So we go to the option, right? So yeah. So that's our preferable technical stack this day, and we're trying to leverage this kind of technology to be a very emergent technology for our clients. And not just building for our clients, we also open source on up development work on GitHub, and we build a product called could store microservices using Istio and polyglot technology like .NET Core, Node.js, etc., etc. And we like to get the feedback from all of you. And for now, I will over to Thắng to share about that kind of open source project and have a lot of demo to you.
Okay.
Yeah.
Thank
Thanks.
you, Phi, for the really interesting information about the service mesh. And now we want to bring up some of real experience that we apply the service mesh and some of the advanced strategy for it to all of you today. So let's open the quick. We have the repository on the GitHub already, and I would like you to feedback on this. And today we will using this for the demo, and we have several of demo today, around 8 demo to apply the service mesh in the system. And now back to the slide. I would like to clone the repository into our local machine first, and then we can using the Docker Compose to up and running the application on the local machine first.
Okay. Okay, so now I already check out the shortcuts into this folder, and I will use the Docker Compose.
Please zoom out.
Yep.
A little bit.
Yep, I checked out about the shortcuts in this folder, and now I will try to use Docker Compose up. Yeah.
Yes, and now we will see the cool store application that on the GitHub. And now after this running, I will show you about the basic business of this application first, and then we will bring up on this stack into the AKS with the Istio already installed there.
Okay, here you are.
Just wait a moment. And this one already integrate with the Identity Server 4. So that means we have the single sign-on mechanism in this. And after you log in, it will bring you back into the home page. And in this home page, we will have several products in here. And when you click to any items, it will show you the details of that products. And we have the inventories information in there as well. And now we're back to the home page.
Yep.
And we have the filter that we can up and down to narrow down the product in this page. So that's it for really simple, because the times of the demo is really limited. So we just want to work through 2 scenarios as well. So now we turn to the analysis a little bit about the cool store projects. In the home page, we have the microservices we call the catalog service that we implement using Node.js. And when you click into any items on the home page, and it will navigate you to the detail that we have 2 microservices there. We have the catalog service with the inventory service that implement using .NET Core. And now, this is all the demo we have today. So let's introduce a little bit about all the demo so you can see the whole picture. We have the gateway, and we will show you how can we configuration the Istio gateways on the tops, on the front doors of the application. And then we will configuration for the virtual service. That means we can routing into all the microservices inside the AKS cluster.
Yeah. The next one, I will introduce to you about the mirror or about the shadow deployment strategy. So it means before we roll out any product to the end user, we need to ensure everything is okay. So no exception, no issue. So we can use mirror or shadow deployment strategy. And we also apply AP setting to get the feedback from the end user before we roll out the new feature.
Yeah, and the next things, after you public the new features to the client, you don't want to deploy it into the production for the first time. So we need some way to delay the traffic and some way to throw some of error into the system, what we call the AKS Engineering. And we would like to have the demo to you today as well. And the next one, after everything goes really good, so we can run out it to the user, but we can run out with a subset of user. Just like some of the product, they want to run out to the set of user, not all the users in the world.
Okay, and the last one, we introduced you about the security. So we will introduce about how can we configure the authentication and authorization with Istio and without any code chain. Yeah.
Okay, let's do it.
So switch to the demo.
So, no, just back to the slides.
Yeah.
So the first demo in this one, let's say we have the end user on the left-hand side and want to access to the AKS. And the first thing, if we don't do anything, and I want to show you that we cannot access to the system. And now we're back to the demo.
Okay, so before we go to the demo, I will introduce you about the environment. So we already create one Kubernetes cluster on AKS with the name AKS MS Build. And I also installed Istio and Helm on that cluster. So now I will show you. So in this cluster, for now we have one node, yeah, one agent. And
is it Istio installed in that?
Yep. And because we already installed the Istio, so when we get the service from the namespace Istio, you will see we also have one public IP for Istio ingress gateway. And we also create one domain coolstore-msbuild.ml, and we already mapped to that IP.
Yep.
So I will go to the Kubernetes dashboard. So in the Kubernetes dashboard, you can see.
So on the microservices in the system, we already inject the sidecars into it.
Yeah, maybe we need to run the dashboard again. Okay. Yep. So we already installed the latest Istio here.
Yeah. And you can see here on the container, we put into the post in the Kubernetes, and we have the Istio proxy on the bottom of that.
Yep. And we also installed coolstore service here. So now I will try to access into the domain coolstore-msbuild.ml, and we cannot access because until now we are still not create the gateway. Yeah. So the first step, I will install the gateway.
Yeah, the thing is because we need to have the gateways that stand in front of the application. So because this is from scratch, so we don't have any application that's binding into that the default gateway that's set up by Istio.
Yep. So we will use Helm to install the gateway Helm chair.
Yeah. Yep. We will show you the script to do it after this demo.
Yep. And now I will show you about the gateway YAML file. Yeah. So in the gateway YAML, it's very simple. We will create one gateway with the name coolstore gateway, and we will link that gateway into ingress gateway of Istio. And this gateway will support some host in coolstore. Yeah. And now I will try to refresh again. And the system row exception 404.
So now that means the request hit to the gateway, but inside of that we don't have any routing already in that. So let's switch to the next demo. And now we will configuration for the virtual service so that we can see on the routing work correctly after this demo. we call that the virtual service, and in this string, we need to have some of virtual service that sit behind of the load balancer, and in this, it's route directly to the open APIs and down the stream to all the microservices behind of that. So let's back to the demo again. And now we try to install the virtual service.
Yeah.
Just look like when you implement the monolith application, let's say the APNet MVC, you have the routing, and now the microservices, you do the same.
Okay, so I also use Helm to install virtual service. And after that, I will try to refresh again. So now, can you see we can access to the cool store?
And now just make sure it's work correctly with the same version in the local machine.
Yeah.
And now click to any items.
Yeah.
So it should work, and now we back to the script to explain a little bit about how can we do the virtual service configuration.
Yep. So this is about the YAML file for the virtual service. And can you see in the virtual service, we need to map the virtual service to the gateway. And this is the cool store gateway. We already created before. And after that, we will configure about the routing. Example, we configure about the routing for the catalog. So when the UL plus catalog, we will redirect to the service open API.
Yeah, just the same with you doing with the Nginx configuration.
Yeah, and about the last one, if you go to the root domain, Istio will redirect to the SPA service, SBA service. Yep. Okay.
So now we go to another demo we call the mirror or the shadow deployment strategy. Let's say
let's say last week we already have a new feature, and the new feature is we build very great features that how do we get the hot item on the cool store, and we already get that feature, but one we need to deploy it into production, and this is the way down into production. Yeah.
So in this demo, actually we maintain two versions of the open API. So that means we have one real open API that's quite stable, and we have another version we call the version 2 that's quite new that I just implemented in the last week. And now we would like to make some of configuration to make sure that all the traffic just on the way down to the version 1 and version 2, but the end user just only can see all the traffic to version 1, and let's do it, and we will show you how can we do it.
Okay, so in order to configure about mirror in the virtual service of the catalog, I will add the mirror section, and in the mirror section, I say I will transfer the request into the version 2. Yeah. So I will run. I will apply that virtual service again. Okay, so now when we try to access the cool store, so you can see
don't have anything different here.
Yeah, nothing changed. Nothing changed.
So now we confirm to using the clearly tool to visualize the mesh, so that we can see the difference in the mesh.
Yep. So this is the clearly, and I will try to.
So I think you need to refresh the page several times so that you can see the signal sync back to the control plant. Okay.
Yep.
So as you see in the middle, we have two versions of the application.
So can you see now we have some request from the Istio gateway to Open API, and from Open API we transfer that request to version 1. And version 1 transfer that request to the catalog service. But besides that, we also have some request from the version 2 to the catalog service. Yeah. So it's run in the shadow.
So that means we can use this feature to test some of the new features you implement, and you want to configuration the shadow so that it runs just the shadows of the system, and the end user doesn't know about this.
Okay. And now after that feature is working well, so we want to get the feedback from the end user.
So that's we turn to the next demo. We call the A/B testing, and now we know we can use several tools to do it, but now in this demo we're using Istio, and with the A/B testing you can see we have two versions of the application, version 1 and version 2, at just the same with the previous demo, but now we have the version 1 and version 2 that we put into the headers of the request into the server, so that we can maintain two of version, and we can configuration to let's say if you have some of experienced customer, or you have some of the enterprise customer of your product, and you want them to use first to get a feedback from them. So in that case, we can configuration to do it.
Yep. So switch to demo, yeah. So when we want to configure about the A/B testing, so in the photo, we also configure in the photo service. And currently, in the photo service, for the catalog, we also have two sessions. The first session, we based on about the header. If exactly version v1, we will forward that request to the open API with the subset v1. If the v2, we will forward to the subset v2. And subset, what is it? So I will scroll down and I will show you about the destination rule. So we also configure about the destination rule for the open API. And in the destination rule, we configure two subsets, one for version 1 and one for version 2.
Yeah, because the Istio have the concept of virtual service and the destination rule that that using the envoy proxy to configuration that. So you can change some of the configuration in the destination rule to apply some of advanced strategy for deployment.
Yeah. So after we apply, and I will try again. So now we are using one extension of the Chrome browser to add the version. So now I will try to add the version v1.
So to make clear, because we need to push the header into the website, so that it will, based on that, to split the traffic out when it runs inside the mesh.
So can you see every request go to the version 1, so you don't see about the REST icon. But now,
actually I want to see the new features.
Yep.
I just implement.
Yeah. So now I will set about the version value is v2, and when I try to refresh again, so can you see this request?
Yeah, you can see on the behind of the title, we have the heart icon that we put it into the version 2. Now the Istio can split the traffic, and based on the configuration to show you the A/B testing in here.
Yeah. Okay.
So now let's turn to the AKS Engineering. And now let's say if we have the feedback, we fit the bugs and everything is fine. So now we have to testing some kinds of work, like we need to delay the traffic, and sometimes we need to throw some of error into system to see how the application behave with that action. So with the Istio, we can do two kinds of action like this. So we call some companies like Netflix, they call the chaos monkey. So let's say we have the monkey in the system that constantly to throw some of exception into the system. So then we can test about the timeouts and about the retry strategy. Is it correct or not in the system? So we can set the stability levels of the system.
Yeah. So again, we will not change any code. And in the past, we cannot do, maybe it's difficult to do it. It means we cannot try to draw exception in the current service. Yeah.
Yeah, just to impress, with Istio service mesh, you don't need to modify the code. You don't need to change the code. You just need to put some of configuration on the Istio.
So now in this diagram, you can see we have the OpenAPI, and OpenAPI will call the catalog service. So I will show you two scenarios. The first scenario, I will try to delay about the request from the OpenAPI to the catalog. And the second scenario, I will try to roll exception.
Yep. And yeah.
Yep. So now I will configure one virtual service for the catalog. And you can see in the virtual service, I will configure about the phone session. And in the phone session, I say I need to delay 10 seconds when we call that request. But one important information here. So you can see here, it's just affect on the version v2 and with the user, with the run tester. So it means the normal user will not affect them.
Yeah, so that means the QA team can access to the sites with the same size with all the rows in the system, but only the tester in the system can test this feature.
Yep. So now after I apply, and I will try to open about the development tool. Yep. I will try to refresh. Yeah, so can you see? It's still...
it's really fast,
yeah,
and then
really fast,
we need to log out and log in with another user with the role tester.
Yeah. So now I will try to log in again with user Thắng. He is a tester.
Yeah.
Yeah. And
now you can see it's really slow because now Istio will try to cap the request and delay it
10
for
seconds.
10 seconds.
Yeah.
And after 10 seconds, we can see on the pictures
yeah.
display here. And in this case, we can see because the code C we implement is quite good, so it don't rule the time of reception.
Yeah. But now if I change about the version v1, and you can see the system will run normally.
Yeah. Yeah. It's normally for all the users.
Yeah.
But only except for the testing user.
Yeah. So the next step, I will show you about the scenario. We want to try to roll some exception. So I will try to roll the HTTP error chip profile. Yeah. And I will try to apply again. And it's also affect on the version 2 and tester user.
Now let's open it, and in the distributed system, you need to wait a little bit for all the service to sync the configuration back to the control plane. So some cases will take 2 or 3 seconds to take effect.
Yep. So now you can see the error of 500.
You can using this for test your application. Let's say this one through the 500 status code, HTTP status code. So we need to go back to the code and maybe we implement some of retry or some configuration or retry in the Istio to overcome this case.
Yeah, but now I would like to impress one thing about the error. It's not confirmed about the catalog service. It's confirmed about the Istio proxy. So I will show you about the log. Yeah.
Yep. We would like to know because we have the catalog service in the system, but it doesn't through the exception. It's only through exception in the middle when it transfers in the wire.
Sorry, sometimes it's a timeout. Yeah.
So let's open the catalog service.
Yep.
And this one is through exception, and the open API casts the exception, and we can see the description is for filter about. That means the chaos monkey to put through the error message into our mesh and into our microservices.
Yeah. And now when before we move on, I also open the log of the catalog, and you can see nothing.
Yeah, we expect to doesn't have any exception in the catalog service. So just run out.
Yeah. So no error.
Yes.
Okay. And we move on. Yeah.
So let's move on into another advanced strategy. And after we testing it, after we do anything to fix the bug, and now we need to have the way to run out it for the user. But we don't try to run out 100% the application to the user because it's quite risky. So we're using some of the strategy we call the canary. And in the canary deployment, we can split the traffic. Let's say we have the version 1, and the new version, we have the version 2. And in the version 2, we only want to have the 30% of the traffic that route to the version 2. But in the version 1, because it's quite stable, so that we can put the weight 70% for that. And we'll do it now, and
yep.
we will see it.
Okay, so now I will configure about the photo service of the catalog again, and now I will split about the traffic to version 1 with 70%, and for version 2 just 30%. Yep. So I will try to apply it again, apply the photo suite again. Yep. And I will try.
We would like to see some of the traffic is randomly to shift to the version 1 and version 2. So like sometimes you can see the heart icon, and sometimes you doesn't see it on the screen. So let's go back to the KLE tool so we can see how many percentage you route into the version 1 and version 2. And let's zoom out a bit.
So I'm sorry. So now I want to get your support. So I'm not sure. Can you try to access into this URL so we can see about the workload? Yeah.
If anybody in here can access to the page, and you can see the traffic is increase or decrease, that based on the request.
Yeah. So you can access into this URL.
Just how about to access to that page, and we go back to the chart, and you will see the difference.
Yeah. So now I will back to about the KLE. Yeah. So no
traffic.
Nothing.
So let's say after we apply this, and we have the 30% for the new version, and then gradually we can shift it more traffic for that. And we go back to the YAML files, and now we would like to have the 70% for the V2.
Yep.
But we can shift it, and we're using the triangular pattern to shift gradually into the version 2, and we can release totally the version 1.
Okay. So now I will set about the version 1 just 30%, and this one 70%. Okay. And I try to apply again. Cool.
And now go back, and we trigger some of the traffic, and
so version 2.
Yes, and go back to the KLE again. What it is?
Okay, because sometimes we need a little bit time, so Istio can synchronize router configuration on the mass. No, because we switch 70% to version 2.
Yeah.
Yeah, it's correct.
So go back to KLE. So just so go back to KLE. Oh, now we can see a lot of traffic in the mesh.
Yeah.
So now you can see the version 2, we have more traffic into the version 2. And that's what we use to deploy our new features in the project we work in our company.
So, and maybe someone help us to log in, but you cannot log in, so this is for 01. Yeah. Okay, so next one.
Yes, go back to the next one, and let's say we're ready to deploy it into the production, right?
Yeah.
But another concern we need to address this here is about the authentication as well. That just we mentioned previous, we need to have the way just to configuration for authentication, and that we doesn't need to change the code. We just put it in the infrastructure level, and you can see here. We have actually in the system, we have 3 roles, either a normal user, we have the admins, and we have the tester. And with that user, let's say if I log in with user tester, and I would like to get the 401 status. But the first thing we need to test to see the web page that you see, is it secure or not?
Yeah.
First.
Okay.
And
okay.
yeah.
So now I will try to refresh again, and you can see everything work well. But maybe I don't believe because so now I want to try to get about the dot without token or without security. So
let's say we get some of the REST API and we put it to access from the browser from another tab.
Yeah, good
and
man.
That's not secure, right? Because the end user can access from anywhere from the browser on any tool. So now we need to configuration the Istio method to deny some of the access like this.
Yep. Okay. For the Istio, we can set up authentication without code changes. And Istio support two kinds of authentication. The first is user authentication by GWT, and the second one is service-to-service authentication, and maybe someone calls it MTOS. But for the scope today, I will show you how can we configure about the end-user authentication. Yep. So now that system is not secure, and we don't need to make any change in the code, and we need to configure in the Istio. So in order to configure, I will run about one helm check to enable about the authentication first, and I will explain to you later.
Yeah. So we need to bind to the identity server 4 that we already have inside the cluster, in the AKS cluster, so that when any access to the system, it will validate the token that you send. If you doesn't have the token, it will reject you in that times and don't allow you to access into the open API.
Okay. So after I apply that YAML file, I will explain to you. So we need to, in order to enable about the authentication, we will implement one policy. And in this policy, we will connect to the service. In this case, it is Open API. And it's quite simple. We will set some information related to about the GWT, like Azure and URL. And beside that, you can see we also can exclude some part like PIN or like health check, because we don't need to authenticate that URL.
So because in the service we have the health check endpoint as well, so we don't need to authentication that endpoint inside the cluster, so that we can close it out.
Yeah. So now after I apply, I will try to refresh again, and can you see? Yeah. Istio will reject that request and row exception 403.
Just to impress, we doesn't write any code to do it.
Yeah. But now if I try to refresh again, it still works because in this request we already set about the token in the header.
Yeah, we have the choice token, and now we try to get a token in here, and we will curl in the terminal to see what happened.
Yeah. Oh, no, but maybe I will try to curl with that token first, yeah.
Yep. So if you doesn't have the token in the header of that request, it should be CD401 status string out. But when we attack the token along with the header, in the header that request, and you should get the data out.
Yep. And now I try to curve again. Yep. Oh, here with the token.
Yep.
And so, you can see I can get about the data.
Yep. And now back to the demo again, and we have the last demo today. We can apply authorization using Istio service method. Well, we don't need to write a code to do the authorize, because in the Istio they have already support the role-based authorize. So in this case, let's say if you log in with the user with the tester, and we will reject them, and that's it for the demo, and we can apply some rules for the traffic between the open API with the other service in the system.
Yeah, but one information here, so, for now, Istio just support role space authorization. So in case in your system, if you want to have some complexity, complicated permission, so we need to compile. Yep.
Yep.
So switch to demo. Yeah. Okay. So firstly, we need to enable the authorization.
So after we enable the authorize, and so that we cannot access to the endpoint anymore. Yep. If we log in with the tested user.
No, now it's deny everyone. It's deny everyone. Yeah, sorry. And yeah, because now we still not grant permission, so it deny everyone. So in order to enable about the authorization, we will do a one cluster role space config. And you have two options. The first option you configure on namespace, and the second option you configure on the service. Yep. On the namespace, it means it will affect to every service belong to that namespace. Yeah. Yeah. But in this case, I just apply on the Open API service.
It's really dynamic and allow you to only apply for one service, or you can apply for on the namespace.
Yeah. And now, yeah. So can you see now? It doesn't care who you are. It will roll exception 403 because I still not grant permission. So I will try to grant permission.
Yes. Yeah. So now we assign some of permission for the user test cannot access to the system.
Yep. And so we need to do we need to write about a service role for the service, and on some method get boss or star, it means every method. Yep. And after that we will do one service role binding to that service role. And in the service role binding, you can see we based on about the information in the token claim. So we only allow the user with the role user and the role admin. So sorry, Thắng, you are starter. Yeah.
We will show you right away.
So I will try again because I'm user.
Yeah.
Oh.
You need to wait a little bit for the.
No. Let me try to log in again.
Because you are using user Thắng. Right?
Yeah, maybe. So I try to log in with my user.
And it should work because it can get on the data out. So, but if you log in with the user Thắng, that means me, and you cannot get the data.
So so before we try to log in with the user Thắng, I will try to copy this token and show you. So you can see.
Yeah. In the short token, actually they have the rows that inject into that token, so that Istio will maybe we will open that token and they will clarify that we have the token with the row over there, so that they can, based on that, to reject the traffic.
So now I will try to log in again with Thắng user and deny.
Yep.
Yeah.
Yep. So that's what we want to show you about the demo about the service mesh and some of the advanced features when we're using it with the AKS. Yeah. So.
Yeah. So I think based on Istio, we can quickly, build a DevOps team and just configuration, and then we let the team to focus on development feature rather than do just for NFR requirements. So I think in the future we can leverage this kind of technology to build a very resilient cluster and very scalable and very observable system.
Thank you for your attention today.
Yeah. Thank you.